Good day, everyone. Today, on the Infinops Insights channel, we will be talking about all main Google Cloud Platform services. Google Cloud is one of the top three major cloud providers alongside Amazon and Microsoft Azure, so it's definitely worth exploring. This is part 2 of our review. To watch the first part, click on the hint. Also, the link will be in the video description. Well, let's not talk too much. My name is Mark. This is the second part of Google Cloud Platform Services overview. Let's get started. Now, let's start with POP and SOP. It involves working with asynchronous message processing and streaming analytics. POP or SOP is a flexible and scalable event bus that allows services within GCP to communicate with each other by sending and receiving messages through specific topics. How does POP and SOP work? Imagine an endless stream of data flowing through your system. POP or SOP organizes this stream, allowing publishers to publish messages to topics and subscribers to efficiently receive them. This is a key tool for building event driven architectures where services can react to events in real time without the need for continuous polling or waiting the data. So, what's the value of this for analytics? POP or SAP allows for integrating and enriching data before it's analyzed and activated using tools like Apache Beam, On Dataflow, BigQuery, and even AI platform. This forms the foundation for creating powerful streaming analytics solutions that can digest huge volumes of data on the fly and turn them into actionable insights. POP or SOP supports various message exchange patterns, including many-to-many, one-to-many, and many-to-one, making it exceptionally adaptable for diverse use cases. From load balancing to instant event processing, POP or SOP becomes the invisible nervous system that keeps your cloud infrastructure alive and responsive. Next, another analytics tool, BigQuery. BigQuery offers the capability to perform SQL queries on selected datasets primarily from any database, from any accessible one, including AWS or Azure, besides allowing separation of CPU intensive processing from the database, especially if it's absent. It also features a set of tools not present in standard queries within databases. Analytics, text analysis, code usage, machine learning, and much more can be done with it. When it comes to networking, it's needed for connecting various GCP services and the internet. It also includes CDN, load balancers, scalars, and DNS. This also includes VPC, which allows for bidirectional communication between virtual machines or containers or serverless tasks and the internet. Essentially, it provides them with an IP address and ports and regulates traffic to and from it. Additionally, I will mention network connectivity. It allows for linking VPC to another external non-GCP interface bypassing the public internet. This can be for improving the channel, reducing losses or interference, or for using a VPN. In Google Cloud, there are several key services that you can use for storing and managing your data. Let's start with cloud storage, which can be compared to Amazon C3. It's a powerful and versatile solution for data storage, offering you the ability to create buckets. A unique feature of cloud storage is that you can choose a region for each bucket, which is important for compliance requirements and performance optimization. Once a bucket is created, it has a fixed region and it cannot be changed, so choosing the region is an important decision. Within each bucket, you can create folders and configure access levels, as well as take advantage of a wide range of data security features, including encryption and access management. Next, there is File Store, a service that can be thought of as a shared folder accessible by multiple systems simultaneously. This is especially useful if you need to provide shared access to files for virtual machines or containers clusters. And last but not the least, Storage Transfer Service. This is our tool for moving data, especially useful when it comes to creating backups or transferring large volumes of data, for example, after working with BigQuery. This service is perfect for automatic data archiving and restoration processes. When it comes to databases, it is important to understand the variety of options available and choose the one that best fits your needs for your project on Google Cloud. Let's start with relational databases. Cloud SQL offers managed versions of MySQL, PostgreSQL, and SQL Server. This is a great choice for traditional applications that require standard SQL database features, including support for web framework, ERP, CRM, e-commerce, and software as a service applications. If you need a database optimized for handling massive volumes of data and providing high availability, Cloud Spanner will be the best choice. This unique solution combines the benefits of the relational model with the scalability of NoSQL systems, making it ideal for global financial systems, gaming, and inventory management. For non-relational databases, we have Firestore, a cloud NoSQL document-oriented database that is perfect for mobile, web, and IoT applications due to its ability to handle complex hierarchical data and provide real-time synchronization. Cloud Bigtable is a good choice for cases where you need NoSQL database performance at the petabyte level. This wide column store is suitable for big data analytics and event-driven applications such as ad tech, recommendation systems, and fraud detection. And finally, if you need ultra fast access to data, Memory Store offers fully managed Redis and memcached instances. This solution is perfect for caching, sessions, gaming leaderboards, and other use cases where the fast data access is required. Next, let's talk about cloud operations. This is the part of Google Cloud that allows us to understand how our cloud behaves. It's about monitoring logs, analytics, and setting up alerts for important events. These are key tools for monitoring the state of our projects and especially important for tracking quota usage. From the perspective of an infrastructure operator, the most interesting thing here is the simplicity with which we can monitor projects. We can quickly obtain data about the system status and react appropriately to changes. Regarding error reporting, this part may be less interesting for us as infrastructure engineers because errors require manual intervention and should be documented in other services. They are not collected automatically, but this tool can be useful for deeper analysis of issues. It's also worth mentioning Trace. This is the tool we use to check for delays in various GCP services. This can be incredibly useful for identifying performance bottlenecks and optimizing our operations. Certainly, one of the key services would be security. Here, it's straightforward. It shows the security posture of the project. It checks whether the project complies with industry standards and displays errors or warnings if there are issues. Additionally, it includes Google Cloud Armor, protection against DDoS attacks, bot attacks, and so on. Security can also incorporate various APIs from the marketplace. For example, there is Secret Manager, which works similarly to its AWS counterpart. There is no need to delve into details here. Moving on to the CI/CD service, Google Build handles this in Google Cloud. It allows us to create Docker containers directly in the cloud. One of its key features is the ability to trigger builds, for example, on every new commit to a Git or Atlassian repository. Now, let's talk about cloud resource repositories. This is a convenient place to store your private repositories, fully integrated with Google's cloud infrastructure. It simplifies code management and its integration with other CI/CD services. Artifact Registry Service as a repository for all your builds and artifacts. It's a kind of library where all versions of your builds are stored and from where they can be distributed to different stages of your development process. And finally, Cloud Deploy. This is the tool that allows us to organize and configure pipelines for deploying our applications. With it, you can set up where and how deployment will be performed, as well as whether approval from third parties is required to initiate the deployment process. Next, let's move on to AI. This encompasses various tools utilizing machine learning and tools for training your own models. There is no particular need to delve deeply into them. The diagram indicates what you can work with in GCP in this regard. Finally, let's discuss integration services. These include Cloud Schedule, Cloud Tasks, Workflow, Event Arc, and application integration. Let's break them down one by one. Cloud Scheduler Essentially, it's similar to AWS CloudWatch, as discussed in previous sections, but many tasks can be scheduled. This can be configured both with the task service, for example, in Compute Engine, or here. Cloud Tasks, functionally, it's similar to Cloud Scheduler with some differences. The main distinction is the concept of a queue and its asynchronous nature. Essentially, when a task begins execution, a task execution queue is initiated. In Cloud Scheduler, tasks will attempt to run simultaneously. For instance, sending over 1,000 requests to a database simultaneously could be disastrous. Here, you can configure them to be sent in groups of 500, for example, but ultimately all requests will be sent. Workflows. This involves creating a group of tasks that are executed in a specific order with a selected schedule, along with logical branching. It's quite similar to Cloud Composer, but has some differences. Event Arc. It allows you to build event driven architectures without having to implement, customize, or maintain the underlying infrastructure. And that's all. Thank you for watching our presentation. Now we definitely have covered all the key services of Google Cloud Platform that can help you in your cloud operations. If you haven't watched the first part, check out our channel. Don't forget to subscribe to the Infinops Insights channel to get insights on managing your cloud resources effectively. Share the video with your colleagues and partners, hit the like button, and stay tuned for our upcoming videos. See you next time.